Thank you for joining this lesson. We are going to handle current electricity 2, a paper 2 session, whereby we are told that the figure below shows 3 resistors, and we are told that the voltmeter reads 4 volts. Then we are told to find the effective resistance. So for us to calculate effective resistance, we first of all have to analyze how these resistors are connected. We can see that the first 2 resistors, which is 6 and 3, are parallel to one another. When 2 parallel resistors are to be replaced with 1 resistor, or when we are finding effective resistance for 2 resistors in parallel, then we get the product of the 2 resistors such that we can have 6 times 3, then divided by 6 plus 3. This becomes 18 out of 9, which is 2. So we have 2 ohms, a resistor that can replace the 2 which are in parallel. Now, the 2 ohm resistor which has replaced 6 and 3 becomes in series with the 8 ohm resistor, such that now, for us to get now the effective resistance, we'll have to consider a 2 ohm resistor and a 8 ohm resistor, but now in series 2 and 8. And when we are getting effective resistance for resistors in series, we just add them directly. So we will have 2 plus 8, and this gives us 10 ohms. Therefore 10 ohms is the effective resistance in this connection. Part 2, we are told to find the current through the 3 ohm resistor. For us to get the current through the 3 ohm resistor, we first of all have to get potential difference there. So what we should understand is that if the voltage drop across the 6 ohm resistor is 4, we've been told that this one reads 4 volts, then since it is in parallel with the 3 ohm resistor, it has also 4 volts. In parallel, components have the same voltage drop. Therefore, we will say that according to Ohm's law, V equals to IR. This means that I is given by V out of R. So for us to get I across the 3 ohm resistor, then we need to get the V there, which is 4, and the resistance of 3, and this gives us 1.333 amperes. So that is the current across, or current passing through the 3 ohm resistor. Part 3, we are finding the potential difference across the 8 ohm resistor. Potential difference, remember, is given by IR. So at the 8 ohm resistor, we have to get the current through it. Therefore, we can get the current through the 6 ohm resistor here. Now that we have voltage across the 6 ohm resistor and the resistance for that resistor, it means current across the 6 ohm resistor is given by V, which is 4, out of 6, the resistance. This will be 0.667 amperes. Therefore, in this connection, we have a current of 1.33, and here a current of 0.667 amperes. Therefore, with 6.667 and 1.33, the current now combines at this junction and flows as 1, because it had split in a parallel connection. Therefore, the total current flowing in this system is going to be 1 plus 1.33 plus 0.667, and this totals to 2.0 amperes. So at the 8 ohm resistor, we shall have the total current flowing in these two combines to flow in the 8 ohm resistor, and we will have 2 amperes and a resistance of 8. And now we will say that the voltage across the 8 ohm resistor is going to be current, which is 2, and 8, which is the resistance, 16.0 volts. So we're going to have 16.0 volts as the voltage across the 8 ohm resistor. Then we're given a part B here, which says that a cell supplies a current of 0.5 amperes when connected to a 2 ohm resistor and 0.25 amperes when connected to a 5 ohm resistor. Find the EMF and the internal resistance of the cell. Find the EMF and the internal resistance of the cell. What we should know is that EMF is usually given by terminal voltage plus the lost voltage in a cell, and we should know that the terminal voltage is due to the external resistor. Therefore, because voltage is given by IR, then we shall have current times external resistor, and the lost voltage is due to the internal resistance of the cell. So current times internal resistance. Then now here we can get two equations and we solve them simultaneously. We are told a current of 0.5, so we shall say EMF equals to 0.5 and 2 as the external resistance plus the same current multiplied by their non-internal resistance. So this one can be called equation 1, and we can simplify it to E equals to 1 plus 0.5 R, equation 1. Then equation 2, we will have E equals to 0.25 times 5 as the external resistor plus 0.25 multiplied by the non-internal resistance. So E equals to 1.25 plus 0.25 R. This one is equation 2. Now expression 1 gives us the EMF. Expression 2 gives us the EMF. This means we can equate the two. We can equate 1 plus 0.5 R with 1.25 plus 0.25 R, because they are both giving us the EMF of the cell. So we can take 0.25 and subtract it here, whereby we remain with 0.25 R equals to 1.25. We subtract 1 such that we get 0.25 this side, and therefore we're going to get R as 1. Therefore, because this is resistance, it's going to have its unit as ohm. Therefore 1 ohm is the internal resistance, and now that we've gotten 1 ohm as the internal resistance, then we can get EMF of the cell by substituting in one of the equations. So when we substitute in the second equation, for example, then we shall have 1.25 plus 0.25 multiplied by 1, which remains 0.25, and this will give us 1.5 volts as the EMF of the cell. Remember to subscribe to this channel and share the link with your friends. Thank you.